Assalamu alaikum, my dear amazing students. Welcome back. Um, first and foremost, I have to tell you the same thing I told the grade 11s. I have a new microphone, so hopefully my voice is a little bit clearer because I know I had a few students tell me my voice wasn't very clear. Hopefully, now it's a little bit clearer. Anyway, we are now at Unit 1.3. Inshallah, as you know, I said I will be posting videos until we finish all the units for the exam. And then once we're done with the units for the exam, inshallah, we'd also be doing some um, extra revision, and that'll be that, inshallah. And what I'm going to do at the end as well is I'm going to compile all the videos into one video. Okay, so that'll be a long video, but at least it will be one video for everything that you need to know. Somebody said that that would be easier. We'll see. Okay, let's go. So we've got extra supplementary practice. Let's have a look. So I've got this here that I want to do. What I would like you to do, as always, is I'd like you to pause the video. I'd like you to do it, and then check your answers with me as I go through with it. So in science, what three changes in science, okay, cause an object to accelerate? So this is something that we have talked about in class, we've talked about many, many times. So inshallah, most of you would get the three changes are basically increase in speed, increase in speed is a form of acceleration. Decrease in speed is also acceleration. Okay, so either speeding up or slowing down, or the last one is changing directions. So all of these are forms of acceleration: changing direction, speeding up, or slowing down. What is the equation for finding the acceleration of an object that is moving in a straight line? Of course, it's going to be acceleration is equal to final velocity or final speed minus initial speed all over time taken. Now, some of you might be thinking, what is this? These symbols, they're very difficult. Well, another way to put it is like this: S2 minus S1, final speed minus initial speed over the time taken. Okay? That's all you have to do. And that is the same as this: final speed minus initial speed. Initial just means the beginning, the first speed, all over time. That is acceleration. So acceleration is change in speed, change in velocity. Graph A, velocity of course is speed with direction, just to remind you. Graph A below plots a race car's speed for 5 seconds. What is the car's rate of acceleration? The car's rate of acceleration is going to be change in speed over time. So we know the time is, look, 1, 2, 3, okay, so it's for 5 seconds. Okay, so it goes from 0 to 5 seconds. So this last point here is 5. So that's 5 seconds. We know the time is 5 seconds. What's the first speed? The first speed is 0. What's the final speed? Final speed is, that's 24, 21, 24, so that's 27, that's 30. So it's going to be 30, because this point here is 30, that's 27. So it's going to be 30 minus 0 over, what's the time? 5 seconds. So it's going to be 30 divided by 5, or 6 meters per second squared. That is the unit for acceleration, 6 meters per second squared. Graph B, on the other hand, let's see if I can just zoom in a little bit. Okay, graph B, oh, that's not what I wanted to do. Oh, now it's all over the place. That's very weird. Okay, let's just zoom out again. Graph B, on the other hand, plots the same race car's speed for a different 5 seconds. What is the car's rate of acceleration? Well, I can tell you right now it's 0. Why is it 0? Because there's no change in speed. You see, it starts at 12, it ends at 12. So what's going to happen there is if we go final speed 0 minus initial speed, final speed 12 minus initial speed 12 equals 0. And divided by 5, 0 divided by 5 equals 0, which means there is no acceleration. There is a speed, but it's constant. It's not changing. So the car is moving at 12 meters per second. But the acceleration is 0. There is no change in speed. The car is just moving at the same speed. Okay? And finally, the definition of acceleration. What is the definition of acceleration? Acceleration is, okay, change in velocity over time. Okay, so the change in velocity over time. Change in speed over time, yeah, okay, officially it's change in velocity. Velocity is speed and direction, and acceleration does have a direction, okay, because it's a vector quantity. So officially it's change in velocity over time. That is the official answer. Okay, let's look at these options over here and see if we can figure out whether they are true or false. This is called modified true or false, which means if it's true, you leave it as it is. If it's false, you have to correct it. First one says, if a train is slowing down, then it is accelerating. Is this true? Yes. Remember we said acceleration is either slowing down, speeding up, or changing directions. The second one says, to find the acceleration of an object moving in a straight line, you must calculate the change in distance for each unit of time. It's not change of distance, it's change of speed. Remember? Change of speed, not distance. Next, a Ferris wheel, which is this here. Remember the Ferris wheel is this big thing and people go on it on theme parks and they look at the whole city. It's in Winter Wonderland, it's in Hawali Park, it's in many places. A Ferris wheel turning at a constant speed of 5 meters per second is not accelerating. Well, it is accelerating. That's actually false. It is accelerating. Why? It's not speeding up, it's not slowing down. It's because it's changing directions. It's like a car going around a roundabout, which means, remember what we said? We said there are 3 conditions for acceleration. Either you slow down, or you speed up, or you change directions. So in the case of a roundabout, a car going around a roundabout, if it's moving in one direction, it's not, and it's moving at constant speed, it's not accelerating. But if it's moving around the roundabout, what's going to happen to it? Over here, the direction changed. Now it's moving this way. Over here, the direction changes again. Now it's moving this way. And since the direction is changing, we call that acceleration. Acceleration is either slowing down, speeding up, or changing directions. Right, number 4. An airplane is flying west at 200 kilometers per hour. 2 hours later, it's flying west at 300 kilometers per hour. The average acceleration is 100 kilometers per hour. Is this true? Let's have a look. What is acceleration? Acceleration equals change in velocity. So it's the final speed minus the initial speed all over the time. What was the final speed? Okay. It was 300. What was the initial speed? 200. What was the time? 2 hours. So that means 100 divided by 2 equals 50. So that is false. It is not 100 kilometers per hour squared. It is 50 kilometers per hour squared. Number 5 says a speed versus time graph for a car's motion is a horizontal line at a speed of 12. The car's acceleration during this time is 12. No, it is 0. Why? Let's understand the question first. If you don't understand the question, you won't be able to answer it. Here is a speed versus time. Speed, time. So the speed is 12 and it's a horizontal line. That means the speed is not changing. It's not slowing down. It's not speeding up. So what's happening here is the acceleration is not 12. The acceleration is 0. لأن we started at 12 and we ended at 12. So then it's 12 minus 12 divided by time is 0. 12 minus 12 is 0 divided by time is 0. So it's actually false, and it's going to be 0. Number 6 says the SI unit for acceleration is kilometers per hour squared. That's also false. This is a unit for acceleration, but this is not the SI unit, not the standard international unit. The standard international unit, as some of you are yelling through the screen, is meters per second squared. Okay. Number 7, the rate at which the velocity of an object changes is the object's rate of, come on, everybody should know this by now. The rate at which the velocity of an object changes is the object's rate of acceleration. Acceleration is change of velocity over time, or the rate of velocity change. An airplane is accelerating at 8 meters per second squared. Each second, its speed increases by 8 meters per second. That's the whole point. Acceleration is change of speed. If it's accelerating at 8 meters per second squared, that means every second it's increasing by 8 meters. If it's decelerating, that means it's slowing down. It's still acceleration, but it's slowing down by 8 meters. Number 9, an airplane is accelerating at negative 8 meters per second. The distance the airplane travels each second is what than the distance it travels during the previous second. So once again, it's going to be 8 meters less than the distance it traveled during the previous second. Because every second it's going 8 meters less. 8 meters less. 8 meters less. So if the plane starts at 1,000 meters per second, which is very, very, very fast, then after 1 second, it would be traveling at 992 meters per second. After 2 seconds, it would be traveling at 984 meters per second, and so on and so forth. Okay? That's what that means. An amusement park ride falls straight down for 4 seconds. Oh, it looks like it's this thing here. Maybe that's what they're talking about. You know, where you sit down on it. I don't know what this is called, but it's scary. I know some of the boys like the scary rides, and some of the girls too. So it falls down for 4 seconds. During this time, the ride accelerates from a speed of 0 to 40. S1, the starter, is 0. S2, the end, equals 40 meters per second. And the time it took to get from here to here is 4 seconds. That's the time. Of course, it's going to ask us to work the acceleration. Acceleration, as we know, equals S2 minus S1 all over the time, which equals 40 minus 0 over 4, which is 10 meters per second squared, which is pretty fast. Okay, so that is almost free fall, really. Oops, oh, that's going to be difficult for me to fix. I don't know how to fix that. What just happened? Okay, I have no idea how I did that. I'm gonna try and oh, that's all it was. Okay, that was cool. I didn't know you could do that. I did not know you could do that. Should we try that one more time? So you're listening to everything I'm saying right now. Wow, you are accurate. That's amazing. Okay. Right. Okay, that's amazing. Right, so the speed is 10 meters per second squared. Anyway, moving on. We're trying to keep this short. Okay, so this is the last thing I want to do. The graph below shows the motion of a runner. What could the runner do to make the slope of the line rise? What could they do? Stop running? No. How could you make the rise go, instead of this, go like this, or go like this? That's what it's asking for. So instead of this, I've got a ruler here, by the way. Another one. Hey, see? Instead of this, I want it to go like this, or like this, really steep. That means I have to cover more distance in less time. So I have to run faster. So I have to increase my speed, if anything. Increase my speed. D. Number 2, members of the Fairview Track Running Club running a 5-kilometer race, what is the distance of the race in meters? Okay, this is where we have to do a conversion. 5 kilometers equals 5,000 meters. Okay, 5,000 meters. Number 3 says, what condition is necessary for an object to make a good reference point? Remember when we're talking about reference points? The object is moving at a constant speed. The object is accelerating. The object is fixed relative to the motion you are trying to describe. The object is large. Of course, the object has to be fixed. If it's being used as a reference point, the object has to be fixed. So it's C. Number 4, two objects traveling at the same speed have different velocities if they start at different times? No. It doesn't have to be starting at the same time. If I'm traveling at 60 kilometers an hour and then the next day someone's traveling at 60 kilometers an hour, we have the same velocity. It doesn't mean we don't have to start at the same time. Travel different distances, again, it doesn't matter. If somebody's traveling at 60 kilometers an hour going to Mecca and somebody's traveling 60 kilometers an hour going to Fahil, they're both going 60 kilometers per hour. Have different masses, once again, that makes no difference, and move in different directions. So they can only have different velocity if they are moving in different directions here, because we said a change in velocity can happen if a person slows down or speeds up or changes direction. Number 5, your family is driving to the beach. You travel 200 kilometers in the first 2 hours. Okay, let's do this carefully. 200 kilometers in 2 hours. And then during the next hour you stop for lunch and only travel 25 kilometers. Next hour, 25 kilometers. طيب, what is it asking? What was your average speed? So average speed average equals total distance divided by total time. I hope you remember this. Total distance divided by total time. Oh man, I slaughtered the word time. Which equals, what's the total distance? 225 kilometers. What's the total time? 3 hours. So for those of you good at maths, you should know that that means 75 kilometers per hour. Okay, very good. 75 kilometers per hour. And the last one says, use the graph to answer question 6. Write your answer on a separate sheet of paper. The graph above shows the motion of a person. Describe the motion. Okay, very easy. The person is moving at constant speed. Okay, so they're not actually, because it's distance, time. And they're moving at a constant speed of 1.5 meters per second. And they cover 15 meters in 10 seconds. And then they stop. See, they stop here. And they stop for 10 seconds. That's it. So they are moving at 1.5 meters every second. How do I know it's 1.5 meters every second? 15, rise, overrun, over 10 seconds. So 15 meters divided by 10 seconds equals 1.5 meters per second. And then they are stopping. Here, at 15, they stopped. They are not moving at all. So they stopped moving for 10 seconds. That's it. That's the motion. Okay. Thank you very much. We kept it less than 20 minutes. Take care. I'll see you in the next one, inshallah.